Hello, I'm Brett Champion, and I'm the Visualization Manager here at Wolfram Research. And today I'll be talking about advances in visualization. We'll look at the newest features and what is coming in the next version, coming soon. That's it.
Good morning. Welcome. My name is Brett Champion. I'm the Visualization Manager here at Wolfram, and today I'm going to be talking about advances in visualization, and we'll spend a little bit of time looking at some of the new features in 12.0, and probably a little bit more than a little bit of time looking at some of the things that are coming in the next version. So before we get started, I'm going to plug the talks for the rest of my team members. They're all in this room. Emmanuel is going to be speaking about geographic visualization immediately following this talk. Nirmal is going to be talking about complex valued visualization at 1 o'clock after lunch. And Min is going to be talking about automated labeling and visualization at 4:30. And as a consequence of them having their own talks, I'm not really going to say anything much about geographic visualization or complex valued visualization or labeling in this one. Which leaves us with a couple major areas for that were improved in version 12.0. The first is visualizing uncertainty with the addition of a round and vector around and some functionality and tooling around them. And so we'll just take a look at a few examples. And so I have a few data sets. The first one is just a list of numbers, and each of them has an associated uncertainty with them. All of these examples that I'm going to be showing have symmetric uncertainty, so same amount above as below the central value. It's not restricted to that. It works generally with the non-symmetric forms as well, but it's a little bit more complicated visually, and I don't know that it necessarily adds that much to the presentation. So as I was saying, we have our first data set, and it just has a list of 15 values, each with some uncertainty. Uncertainty is relatively large, just so that the people in the back have some chance of seeing the error bars. And so the support is not across all 150 visualization functions that we have at the moment. For some of them, it doesn't quite make as much sense. And for some of them, it perhaps still makes sense, but isn't of the same importance level, and so we didn't. We haven't done them yet. In general, with a lot of the features, we sort of roll them out. You know, we start them at the top of the visualization hill, and then they fall downhill through following versions. And so we have the list plots and bar chart, which are probably 98% of what people visualize uncertainty with. And these probably look reasonably familiar to everybody. You have points or bars, and then you have the uncertainty represented by these lines, which we'll get into a little bit more, but is we're calling interval markers as the general term, which allows us to add more forms of uncertainty down the road without having locked ourselves into, say, error bars as terminology or something. And so the interval markers, we can change how they look. So list line plot at the moment is still using the vertical line segments. I can set interval markers to bands, and then I get continuous representations of uncertainty along the curve. We can change the style of the interval markers. So for the list line plot, where we have this default fences form, I've changed it to black. I know that that's perhaps not the most obvious thing on this projector. It's a little bit clearer on up close and on a smaller screen. For the bands, I turned them yellow. I also made them opaque because otherwise the filling by default is partially transparent, and you have even less chance of seeing that on this projector from the back row. And so you have the ability to control how the uncertainty is represented and how it is styled. So we also support, where it makes sense, uncertainty on a per dimension basis. So here's X and Y values, each with their own uncertainty. And there's a couple of representations that we have for that. The default is using crosshairs, which we see on the left. We also have the ability to represent it as ellipses, which by setting interval markers again on the right. And if you have vector around, then that allows you a way to represent correlated uncertainty between the X and Y dimensions. And so if you look at vector around, you have a point, and then you have a correlation matrix here. And I used mean around to get a bunch of those from some randomly generated points. And when we look at the ellipses with those, then they are no longer axis aligned because of the correlation. So for 12.1, we're adding uncertainty to a couple of the 3D visualizations, in particular list point plot 3D and list plot 3D. Drag that out a little bit bigger so it's not quite so small next to its neighbor. And in this case, the interval markers will be a little bit different. At least initially, we're not supporting the surface version of bands in listplot3D at the moment. I don't think it would necessarily be that difficult to do, but I'm also not sure that if you have an additional surface above and below that you're going to be able to see that much and make a meaningful, draw meaningful conclusions from it. And as in 2D, you can have per axis or per dimension uncertainty. So this is again, so we have uncertainty in X, Y, and Z, and you get crosshairs going in every which direction. And so that is where we're at in broad terms with uncertainty at the moment for visualization. The next thing I'm going to talk about briefly is multi-panel displays. So this is an ongoing project into how to represent data in nice-looking grids of graphics. And so this is just a relatively simple example. I have 3 cities, Champaign, Minneapolis, Memphis, and I've grabbed their temperature data since the start of the year. And normally if I feed this into date list plot, it would give me 3 curves. They would be different colors, and they would intersect each other and potentially be kind of noisy and difficult to read. So instead, in this case, I'm going to say plot layout goes to column, and then that is giving me 3 separate panels, each one with a curve. All 3 of them have the same scales on them. And what I mean by the same scales is twofold. So the clearer one is that the x-axis, the January through beginning of November, is the same for all of them. So if you take a vertical slice, then September 1st is the same vertical pixel all the way up. The slightly more subtle one is that The Y ranges are the same on all of them. The ticks look a little bit different because we're avoiding colliding ticks at the corners here. But 0 to 20 here is the same as 0 to 20 here, is the same as 0 to 20 there if I was 7 feet tall. Or had really long arms. And so this is an alternate form, an alternate way of presenting your data. Again, this is available in most of the list plotting functions at the moment. And in addition to column, there's row, there's a grid form where you can say I want 2 columns or 3 columns or 2 rows, whatever. And as I was saying, right now it's supported in 12.0 in most of the list plot functions, list plot, list line plot, log plots, date list plot, obviously. The exception that I can think of off the top of my head is the stacked list plot, which already does its own thing with multiple data sets and sort of splitting it out into multiple panels sort of is counter to its mission already. And then in 12.1, we may pick up a couple more viz functions that support this sort of output, depending on how the time shakes out and what other projects get deemed more important. So, okay. Is there a question?
Yeah. What happens if one of the graphs is the y-axis for 1,000?
So
I ask because of the text will make more. When I do graphics column, I have a problem.
right, and so this is not using graphics column. So graphics column, graphics grid, graphics row also have some improvements in 12.0. I don't have any examples of them on the screen right now or in this talk. But in general, those functions by default, if you have things like this, and so the issue is traditionally, if you did say a graphics column, and you had 0 to 1 on this axis and 0 to 1,000 on this axis, then graphics column would have each of the graphics the same width, but for this one that went up to 1,000, a little bit more of the text would be, there would be more space on the left-hand side because it had to represent the 1,000, and then this line would match up to like here or something on the bottom one. That should not happen in 12.0. In 12.0, graphics column and graphics row and graphics grid make sure that the space outside the frame is the same for all the plots. And so what it will do is this one will know that this one went out to 1,000 and had extra space over here. So it will add the same amount of extra space here so that the frame edges will line up. Multiple what?
Multiple trends and multiple plots.
I have ideas on how to do it, I hope to get there. Well, I'm sure we'll get there eventually. It's not going to happen for 12.1, I'm sure. But it then becomes a question of, basically an indexing problem. So if I have 2 curves per plot, how do I control which 2 curves? How do I control, say, plot styling or filling or this sort of thing? So if I have 2 curves and I want to fill from one to the other, fill between them, that syntax gets a little bit more complicated. So we aren't there yet, but I have ideas on what the design for that should be. Okay.
Could you show us what you have behind the icon? What kind of options are you using?
I think that one's just setting aspect ratio, and it's turning the labels on for each one. And what's that? Mm-hmm. Right, and that is in the pipeline, but not. I'm not prepared to speak about it today.
There is a code on the internet.
I mean, not only is there code in the internet, there's a version of that in the function repository. Okay, so moving on. So briefly, so now we're going to be looking at forthcoming 12.1 features. Region Plot 3D will be able to work on multiple regions, which it hasn't been able to do until now. I think it was one of the few exceptions to the working on multiple forms. So here I have 3 cylinders, plot them all at the same time. They all get different colors. And as I say, that's a long time coming. Contour Plot 3D is gaining the ability to plot over a region, which most of the other symbolic visualization functions have had for a couple of versions now. And so here I have some function that I picked, and we're plotting it over the unit ball. And it looks kind of cool. And what you may notice is that in this plot there are 2 contours, the yellow one and the blue one. And then there's also the actual ball. And so this is being controlled by a new option, which is called region boundary style. And I can turn it off, in which case we don't get that ball. Or I can specify that it's a particular color, in this case green, which, I'm not sure that I would use green as a default for most things, but hopefully it shows up reasonably well. And what we found is that this is a useful technique for a lot of these things that are generating. What they generate is a subset of the space that they're being plotted over. And so contour plot, you have your space and then you're doing slices through it. And especially when you have plotting over some arbitrary region, you sort of lose that information about what the space originally was. And so we're adding that boundary style in as a reference for that. And that will then roll out to additional functions where it's especially useful. That's working now. If you were at Yutsu's talk on Monday, then you saw that we are adding hatching and other shading techniques. And the hatching I'm especially excited for visualization purposes. And so I think there's still some design work into exactly what the syntax for this is going to be and what the defaults are. But I just want to point out that we can use it as a chart style. We can use it for filling style. So David, you're saying you want me to make it bigger? And
can you make it a little busier, please? Because it's not. And then make it flat.
Okay. I have not tried wrapping a dynamic around it and having the lines. But I'm going to try that, and you guys are going to get the credit. But so anyway, the hatching and the new shaders should work throughout the visualization functions in the places where you would expect them to.
Points in list block, you can use hatching instead of fill now.
The points themselves I don't know that hatching will do anything with them. Some of the other filling in list plot or whatnot, it may come into play. Whether or not that's what you actually want, I'm not sure. And so now I'm going to spend the last 5 minutes going through some improvements to vector plotting that we've been working on. So how many people were at Tuesday morning's talk by the Maymans on computational mindfulness? A few people. So that inspired me a little bit for this talk. And so part of their talk was, basically spot the differences between two images. And I thought I would do that with the vector plots, with one vector plot. So the left-hand one is going to be version 12. The right-hand one is the forthcoming version. And there's going to be some differences. They might be a little bit subtle. There we go. Especially if I only put it on screen for half a second. Good. And so there are multiple things that are going on here, some of which might be subtle. So obviously the vectors are larger. By default, in the new design, the vectors all have the same length, rather than being scaled according to their norms. The reason for this is, obvious, is that it was sort of very easy previously to have big empty spaces in your plot. And when there's empty spaces, you don't see the vector, and you know it's small, but you have no idea which direction it's pointing. And so we've gone to constant size vectors using a color function to represent the norm. So that's 1 and 2. The third, which is the subtle one, is that the points are actually laid out differently. So these are on a rectangular grid. It's like 15 by 15-ish, something like that. This is actually on a hexagonal pattern. And that gives us a couple of things. One, it breaks up the grid, and so you get a little bit less optical illusion and seeing patterns that aren't necessarily there. The other is that it actually allows us to use larger vectors, larger arrows, because you're able to pack them more tightly without them intersecting and overlapping each other. So how this is done, we have a new option called vector scaling. It is none by default, which means don't scale at all. I can set it to automatic, in which case it will go back to a scaled version where you have some amount of proportional arrow length vector norms. You can do log. There's also a square root version. In combination with the other options, the log tends to be not that different. Because one of the other things that we added is vector range. This is similar to plot range except for the vector norms. So this is an extreme pathological case. We're dividing by the norm cubed, and so there's one vector near 0 that has norm effectively infinity, and everything else previously got washed out. And if we look at, oh yay, that bug. Okay. Why? That should have been fixed in this build. Anyway. So if we look at the distribution of the vector lengths in this plot, and I will come over and read them because maybe David has a chance in the front row. No, okay. So this is going from 0 to about 1. And so that infinite-sized vector in the middle isn't being shown at all. Really it is being shown. It just happens that everything basically above 1 has been clipped to an automatically determined 1. And by setting clipping style, I can see those vectors in black here. If I set none, then we get a hole in the plot where we clipped, similar to what might happen with plot or plot 3D or density plot. I can specify an explicit set of norms to use, in this case, all of them, or a numeric range, 0 to 10, in which case we get fewer black ones in the middle. And we'll see if that, okay. Vector aspect ratio, which controls the length to width of the vectors, sort of within these boxes. So if I change that to 2/3 from its default 1/4-ish, then I get sort of thicker vector markers in this case. Vector points, as I mentioned, we have hexagonal. We also have ways of doing non-regular generated vector points, which catches curves in some ways a lot better than any type of regular or semi-regular version does. And it's especially good in the case where you have a region function or are over a non-rectangular domain. And so especially this one on the left, and both of these capture the fact that we're plotting over a disk much better than this one does, which almost looks like it's just a square rotated 45 degrees. And then again, similar to what we saw with complex plot or contour plot 3D, this has region boundary style, and in 2D we also pick up region filling style, which allows us to control what the fill color is. In 3D, the fill color would just sort of get in the way, and we don't necessarily have a good way of rendering it right now anyway. So that is 2 minutes past my time. I'm going to stop and allow Emmanuel to come set up his computer, and while he's doing that, I will answer a question. So, thank you.